This is a video for Dr. Hansen's class, as well as anyone else who could benefit from this information on Streamflow measurements, because it took me a while to find some good resources online and figure things out. I learned best from hands-on experience. So I'll share this with you. Just know that this is kind of basic, introductory stuff, and it's not entirely comprehensive. Also, making a video is not easy, and just keep that in mind. Hello and welcome. My name is Austin, and I'm going to briefly explain how to take some streamflow measurements, since you're probably going to want to be doing that with your environmental site assessments. And in order to get a flow rate in a stream, we need to be able to measure three things: the cross-sectional area of the stream, combination of width and depth at certain intervals. We also need to measure velocity of the water in the stream. Here we have a flow meter hooked up to a sensor, and that's going to give us velocity. And then this weighting rod is used to measure depths at specific increments along the cross-section of the stream. Before you take your stream flow measurements, you're going to want to scope out a good area to take it in, because not all areas of the stream are created equal, and some of them will give you bad data. So here's a few things to consider. Okay, so this is an example of kind of an area of no flow where the water is just pooling up along the banks. You can't get a measurement here, not a good one at least. Over here is a good example of what not to measure in. A lot of rocks in the stream, it's very turbulent. You're not going to get a good measurement there. Very uneven bottom. Yeah, up here is a fairly nice spot of the river. Not too many obstructions. As you can see, it's relatively, doesn't look like there's as much turbulence, and it's a pretty even cross-section of the area. That's another thing to remember: avoid bends in the river because flow is more uneven. Okay, so now I'm in a good part of the river that I want to measure, and the next step would be to stretch a measuring tape across the width of the river. Take your flow measurements at set intervals measured out across the river. But that's pretty easy, so I'm not going to teach you that. You should learn how the weighting rod works. This is the bottom of the weighting rod where the sensor is. It's got this flat piece on there, and that goes on the bottom of the stream. You're going to want to place this somewhere when you go to take your flow measurement, such that it's not obstructed by any rocks. Placing the sensor right here behind a big rock might not be the best idea. There's a more open space back here that I think will work better, unobstructed by rocks. Alright, so this weighting rod is in English units. Works pretty well. Take a look at it here. Here at the top, we're going to use that to help calibrate the depth of the sensor. And it's a pretty interesting rod. Triple hash markings, double hash markings, and single hash markings. The triple hash markings indicate 1 foot increments. The double hash indicate half-foot increments. And all the single hash markings on the weighting rod indicate, what do they indicate? Oh, they indicate 1/10 foot increments. So there's 10 markings in a foot. So that brings me to the next piece of the weighting rod, which is this top piece right here, marked 0 through 10. And then you've also got this column here that adjusts up and down. That's what the sensor's mounted to, and it's marked off at 0, 1, 2, and so on. So if we go and look right now to see what our depth is, we can see that it's right there at the first triple hash mark. Don't mind the water that's going up higher on it, because that's just from the turbulence. So this means we're at a depth of 1 foot. Alright, so when you're operating in a stream of less than 2.5 feet, you're going to use a 60% depth rule. Of the total depth from the surface of the water to the bottom of the stream, your sensor should be 60% of the way to the bottom of the stream. About 2/3. Another way to look at that is, you know, if you're in a foot of water like we are, you're going to want to have your sensor 6/10 of a foot below the water surface. So we're at a 1 foot depth right now, and so this is pretty easy. What we need to do is pulling on this little lever. So we need to adjust the number 1 marking to the 0 spot, meaning it's exactly at 1 foot. It's not 1/10 of a foot above 1 foot, or it's not 6/10 of a foot above 1 foot. Okay, so my number 1 marker here on the rod is now set at 0, just about. And so we're ready now to take our flow measurement. This particular sensor needs to point directly into the stream flow, parallel. Other sensors might go perpendicular to the stream flow, but this one goes head on. Imagine now, if you will, that you were in 1.5 feet of water. So alright, so again, if you were in 1.5 feet of water, there's 1/2 foot, there's 1 foot, and then this is another 1/2 foot. So this is 1.5 feet of water. Up here, you would want to set that such that the number 1 lined it up with the 5 right here. So that would be, you know, 1.5 feet, so to speak. More like 1 foot and 5/10 of a foot. So that's how that measures. And that will get you to set the sensor 60% of the depth of the stream. Now, as you take your stream flow measurement, you're going to want to hold this rod straight up and down in the water. It's important that you don't stand in front of the sensor, but you can stand off to the side, or that's usually the best place to stand. Yeah. Now I've turned this on, and we're going to get a reading here in feet per second. That's our velocity, and it's going to go up and down a bit, and some models of flow meters are more accurate than others, but if we take multiple observations over the course of a minute, we should get a pretty good idea of what the average flow velocity is in this stream. So the next step would simply be to you know, mark out a little ways from one of your edges, and then proceed in set intervals to measure the rest of the stream. At the end, you can either calculate it yourself, what the stream flow rate is in cubic feet per second or cubic meters per second. But some of the nicer flow meters will actually calculate the flow rate for you. Do you know why that the sensor should be set at 60% of the depth of water? It's because at 60% deep in the water, you're likely to have nice, stable, even flow that's representative of that part of the stream. If you were right at the bottom, you know, there's a lot of turbulence off the bottom of the stream, and same if you're at the very top of the stream. You know, chances are you might have more turbulence or the water's moving more slowly. So you just need a nice part of the stream with laminar flow. This is another flow meter that I have with me, and as you can see, this setup is a bit different. Some newer systems have it so you can mount the logger to your wading rod. That makes it a little easier to operate and work with. One of the unique things about this setup is the rod is set up for metric measurements. Alright, so this rod here is actually metric, and so the hash marks mean different things on the metric rod. And how do you know if it's a metric rod? Well, for one, the top looks different. You have here it set up to 0 to 10, but they're much closer together. You could also do it by measuring the distance between single hash marks is a 2 centimeter, whereas on the English rod it was 1/10 of a foot. The 2 hash marks on the metric rod indicates a 10 centimeter interval. The triple hash mark on the metric rod indicates a ½ meter interval, or 5 10 centimeter intervals, or 50 centimeters. 60% depth on this metric rod is conceptually the same as calibrating the depth on the English rod. If we look down here, right now, 32 centimeters, because there's the ½ centimeter mark, that would be 40 centimeter mark, and 30 centimeter mark is right below the surface. So it's about 32 centimeters. Being at a depth of 32 centimeters means that you need to come and set this such that the number 3 is at the 2 spot right there. So in other words, we have 3 10 centimeter increments plus 2 centimeters means we should set it like so. There we go, right there. That's what you want. And as you can see, if I were to pull this up, the flow sensor is now set at 60% depth. So this system is a little bit nicer. We can view flow in real time, as well as have it calculate flow for us using its profile. But let's just get an idea of what the flow is in real time and compare it to the other one. So it's measuring over time, and it's telling me that we're getting a velocity of about 2.16. As a note on units, I just realized that on those measurements we just took, you know, the wading rod is in metric, flow meter was measuring in cubic feet per second. That's not really a big deal. You can easily convert between cubic feet per second and meters per second, or whatever for your study. Oftentimes flow rate is reported in cubic feet per second, so that's something good to know. Just a couple more things, and that is if the stream you're trying to measure is really deep and the water's flowing really fast, you're going to want to take some extra precautions. You know, maybe find a different way to measure it besides wading out there and risking drowning or losing your equipment or something. Also, if there's no water in the stream, you know, if it's just a dry stream bed, you're not going to get much of a reading off of that. And one more thing, if you're measuring your stream and there's hardly any water in it at all, but it is flowing, you know, you may not get your sensor into the water and you're not going to get a good flow measurement. So just keep that in mind. You just report that it's, you know, well below 1/10 of a cubic foot per second or something like that. Also, there's one other really important part of equipment that you take with you, aside from your flow meter, your wading rod, and your sensor, and your measuring tape, and that is your waders. Make sure you have your waders.